Welcome back. So today we will be talking about time. We will talk about time in detail, like from start till the end. So first of all, let's talk about the history of time. When first time we'll talk about Newtonian physics. Newton. Newton, okay. What Newton said about time was that no matter where we are and what we are doing, the the passage of time will remain the same. In simple words, what Newton tried to say is that time is constant. Time is constant. And that we all know it's not true. Time is relative. Time is changing. It can increase, decrease depending on the observer. So that's why the physics of Newton has the very essence, which is time, essence missing, which is time. Okay, so then let's suppose we have the formula F equal ma or P equal mc. This is the most common one because we know that this is used in where when collision happens. When collision happens, plus the very famous E equal mc square, the one and only equation which is above all equations, that mass, something with mass, this shows, wait again over here, E rest, something as stationary, what energy it could have. Okay, this, in this, time is missing. Time is missing. Okay, so again Newton said time is constant no matter. So what is he missing? He's saying gravitational force, gravitational force or strength, then speed or velocity, both don't change the time being observed. This is Newtonian mechanics. For a short example is that if this is a train moving in this direction, and we want to measure its time or its position over here, we have to measure this position x. What we will do is that we will measure this distance, the distance which the distance which is, okay wait, what we can do to measure x. what we could do is that measure t time to travel from this point till this point and till this point. So we can say full time t, the big T, and velocity moving at. So what Newton would do is that he would do S equal Vt minus x. Whatever velocity, whatever value he would get here, he would put that value, or now we have these, and this x would be s minus x. So this is what he would make, s equal Vt minus s minus x. This is wait, let me zoom in. Newton way of thinking. This is how he would think of this scenario. Experiment. Newton's way of thinking. Okay, but now, right till now we have taken we have till now we took time as a constant value. We didn't say time changes or not. But now let's come to Einstein's way of thinking. Einstein way of thinking about time. How Newton imagined what time is. He said that time is not constant. And when he said that, many people opposed him. They said that how could you say something which the great scientist Newton said is constant? How could you oppose it? So his best example he gave was, you're standing in the middle. Suppose you're standing in the middle. This is his best example. I like this example. You're standing in the middle. This x and this x, they are related to each other, equal to each other, not related, equal. What he said is, if this is first scenario, first of all, this is we are right now we are what is it? We are stationary. This is the best example he gave. If there is thunderstorm on this in this area, let me make thunderstorm, and thunderstorm in this direction. What will happen is a shock which is this person absorbs will be at same interval of time. Now, what's different in this? Nothing, right? But imagine the same scenario. If you're on this train, let's suppose it's a train, and you're moving on this train in this direction, what you will see is that this thunder storm, this thunderstorm, this thunder will strike ground first. Observer on train. So, and vice versa, second after first. Okay? So, what does it show? Here, this is a relative motion. Relative motion. Observation of things from different observer frame of reference. The one who is stationary will absorb or will have the same, will see the thunderbolt strike the ground at the same time. On the other hand, the one who is moving with velocity, certain velocity, will see first. But again, speed close to c. Then again, when we talked about c, what is c? What is c? C is speed of light, and this speed of light is constant no matter where you go. This speed will stay the same, which is the value is 299792458. This meter per second. This value won't change regardless of your frame of reference. And if I would like to draw a diagram here, this line over here, this is, I think, what was space and time. No. Yeah. This C. So here what we will see is that all these speeds are less than c. Okay, are less than the speed of light. Impossible to have the velocity below the line. And what does this line make? This is a 45 degree graph the angle is making. Plus, okay, there's one more example of time dilation or